Hi, and welcome to TEMEKO. In this video, we will go through the concepts that you may already know a little about. These concepts are the mechanical power and efficiency of some machine or appliance. During the video, we are going to learn how we can determine this power mathematically and also learn how the efficiency of some machine is related to the mechanical power it produces. Let's get started then. If you still recall, we learned in the previous video that a force is doing some work on the object if the object is compelled to move by a certain amount to the direction of the force. Now think about this. Could there also be a way to describe the relation between the work done and the amount of time that goes into the work? Yes, there is. And how we can do that is by the concept of mechanical power. Because as you see, the definition of mechanical power is the amount of work performed per unit of time. Let me explain this further by using some example. Think about the scenario in which we have an elevator that is lifted by an ordinary electric motor. As you can imagine, the electric motor is doing some work to lift this elevator up, which also takes a certain amount of time. Now, for demonstration purposes, let's change the ordinary motor with a very modern, nice-looking electric motor. You may already know how this will affect the time that goes into the elevator lifting process. It decreases, right? That is what's going to happen. However, it's important to notice that even if the lifting time decreases, the amount of necessary work to lift the elevator stays the same because the weight and vertical displacement of the elevator also have remained the same. What does this tell us about the difference between the two presented motors? It tells us that this modern electric motor has more mechanical power to lift the elevator than the ordinary one because it is doing the same work by using less time to do it. We can express this mechanical power in mathematical form as follows. P equals du by dt, where du is the amount of work done and dt is the time that goes into the work process. As you have already learned, the work done is related to the displacement of the object that is caused by the applied external force. Therefore, we can also express this equation as follows. P equals f dot dr by dt equals f dot dr by dt, which finally becomes P equals f dot v. You may be asking, how about the mechanical efficiency of the machine then? What does it tell us about the behavior of the machine, and in which way does efficiency relate to its power? These are good questions that should come into your head when you are comparing mechanical machines or appliances to each other. The efficiency information related to the mechanical machine tells us, usually, how well we can utilize the power of the machine it produces. In other words, how much of the work the machine produces goes into useful work. It's possible for us to determine the mechanical efficiency of the machine or appliance by using the following equation. Epsilon equals power output by power input. We can also think of the mechanical efficiency in the aspect of energy as a relation between the energy that the machine or appliance takes and the amount of useful converted energy that it gives. This relation can be written as follows. Epsilon equals energy output by energy input. It's good to keep in mind that no one has yet been able to invent a machine or appliance of which the efficiency is 1. Why is that? Well, the simple reason is because of frictional forces that are always present in machines or appliances which consist of multiple moving parts. That's why some of the work that is produced always goes into overcoming these forces. Hopefully after watching this video, you know what is meant by the mechanical power of some machine and appliance, and you also know how to determine this power. You also understand that the power isn't the only information that tells us how good the machine or appliance performs, but efficiency is also an important criterion that you need to consider while making a comparison between two machines or appliances. Thanks for watching and have a nice day.